It is important to stick with the professional vocabulary of your problem domain or application domain. And of course, you need to be able to listen to people who are expert users of the system, capture their knowledge, and essentially stick with their vocabulary and do not invent your own vocabulary, because this would be pretty big disadvantage in your system design. So we need to listen to someone who is somewhat also dissatisfied user, possibly, with the previous version of the system, and identify basically lack of features of or specific problems that exist there. So that also can contribute to the vocabulary to use. So vocabulary that the people use typically are good versions of nouns that correspond to classes and objects in our system, verbs that specify operations, and other design pattern style words or process-oriented or task-oriented phrases that suggest iterations or loops or commitments, like saving information, and adjectives that can also contribute to understanding of our classes, such as storable, concurrent, registered, bounded, licensed, and so forth. So of course we begin with the formal description of the system, and this is another example of a business requirement document that describes provides good business description of the system. And of course this becomes something that can be used to start recognizing and writing use case documentation. So basically transforming this summary business requirement document into a functional specification. So we mentioned this class responsibilities collaboration cards to be used to discover object in the system. And normally you have this CRC session, or sometimes multiple sessions, where somebody is facilitating and the meeting, and somebody is simulating the system by talking about which objects send messages to each other, and people take turns and contribute to this activities. So some of the weaknesses in the requirements document, the lack of information, can be also discovered in such very proactive design session. So as we discussed, part of this activity is to discover classes. So the blank cards typically begin to fill in with an ideas, and basically we just want to be able to capture what is the class name. So typically, just as we discover a specific class, we start writing the class name at the top. Sometimes if classes can be in relationships, such as, for instance, we can have multiple types of aircraft in the system potentially, right? So we can have different types of aircraft. So this could be a potential candidacy for hierarchical relationship between the classes. So if we can identify superclasses and subclasses, or base classes and derived classes at this stage, it's possible to record it also on this card. And as we write down the set of classes and give names to our classes, we want to stick to our application or problem domain vocabulary. In the second iteration, as we already have written down some of these cards, we want to examine the set of classes that we have, and potentially we could name our customer a user. Sometimes it could be a plural version versus single version, like this. So we need to essentially merge these concepts into something that we decide on. So if we decide on a customer, we just say, let's not use these, but rather use a customer to be our class representing this concept. Right, and of course, as we move along, we always can discover new classes. The classes were still not present in our system. So then, as we have a substantial set of classes, again, we focus on a set of responsibilities and answer in this section of the CRC card. We just want to write down the answer to the question, what is this class responsible for? And again, from this initial early stages of capturing the structure of our system, we would like to stick with the proper vocabulary, using not inventing our own descriptions of things, but rather using the language that the expert users are using in this system, in this specific domain. And the next activity is to identify collaborations, as we discussed already. Information about subclasses and superclasses can also become available at this stage, so we can record this information as well. So once again, you may discover that you have two types of reservation lists in the system: confirmed reservations and waiting reservation list. So there could be differences in operations and differences in data attributes stored by these classes internally. However, you may discover that there is plenty of common features, common data attributes and common operation between them. Then it's possible to actually create a reservation list, which is a base class, and have both waiting list, okay, and confirmed reservation list derived from this base or superclass idea of a reservation list. In other words, if you have a similar set of data attributes and similar set of operations inside both of these, the common parts could be given to the base class, and having having more concrete versions of reservation list right here as we work on our airline reservation system, just be a subclasses of the superclass. So discovery of these things could be done at the very early stages, and this can be very successful direction, because it just helps better understanding of the problem.